Hello everybody, I'm Nick, and this video I'm going to show you 4 C# features that you probably shouldn't be using. This is all very subjective and it's up to you to choose whether you want to actually make use of what I'm going to talk about in this video or not. Don't feel like if you're using them that you're bad in programming or anything like that. This is more about me showing you what I'm doing in my personal coding sessions and what I'm not using, and hopefully you find that useful and you can apply it to your own code. So without any further ado, let's go straight into the code, and let's go with the first feature that many of you might not even know is a feature, but it's called labels and goto. Now very quickly, let me explain what labels and goto is. Let's say I have console.writeLine and then start here. And then I'm gonna copy that 3 times. So we have middle and we have end. So middle and end. So nice and easy. So if I run this program, you will see in the console, if I could click the button, you will see start, middle and end, exactly as you'd expected. But if I go here and here, and in here I say end, and I put a semicolon, or whatever this symbol is called, the 2 dots. First, you might have not even seen this code before. This is called a label, and this basically tells the compiler that this line of code or this spot in the code has a name. It's called end, and I'm gonna say here go to end. And as you can see, Rider actually picked it up, and this middle line now is grayed out. And it's grayed out because if I run the code, it will actually skip execution and go from goto straight to end. So it's quite an interesting feature. And I actually, when I'm doing things for myself personally, I'm still using this because you can get out of loops easily and break flows. But when I'm writing code that other people will see and they will need to understand, I'm never using this. And I've actually never seen this used in a professional environment ever. It's usually a code smell. And the reason for that is that you have an expected code flow, right? Top to bottom through methods. But this thing actually breaks the expected code flow. And you can go from, basically you can do this and go to start. So if I had another one here and I said start, and then at the end, I can say go to start. And then you're caught in this infinite loop. You can actually make loops with it. And, you know, this is not readable code because you have to think in your mind, the flow will go here, and then you go here, and then we'll go here, and then we'll go. So basically don't use it. Let me quickly show you one of the use cases, like a very niche use case that you still should probably refactor, and I'll explain why. Let's say we have 2 nested loops, and then we have a sum of numbers, so I plus j. And then we want to say that if this sum equals 50, so when basically this is 50 and this is 50, or this is, I'm bad at math, then what we want to do is we want to end this. So I'm going to say console.writeLine start. I'm gonna say writeLine end, and I'm gonna say here console.writeLine end of loop. And what I want to do is when this sum equals 50, I want to break out of both of these loops without having to call break twice, even outside, to detect a break. So what you can do instead is say go to end, and then I'm going to create an end label here. Not endpoint, end. And now if I run this, what you think should probably happen will happen. We are skipping this because the flow goes from go to end straight outside of the loops and to the end console print. So it's an interesting feature, but you should not use it because it can really cause deceiving flows in your application. It's very hard to debug as well. So please don't use this. The next feature is called Lambda-based getter-only auto properties. So back in C# 7 something, we got the way to create what seems to be a property in this fashion using a Lambda pointer. And then this can be called as, basically, if I create a constructor, it can be called as a property. It looks like a property. The ID is calling it a property, which is a property you cannot set, of course. So if I try to do GUID equals empty, it will tell me, no, this is a read-only property. You cannot, it doesn't have a setter. The interesting thing about this feature is that it can be very deceiving if you don't know exactly what the compiler is doing. And I'll explain why right now, before I dive into this actual class. I'm going to go to the program and show you this piece of code. So what you have here is an execution unit class, which has a unit ID, which is a GUID that we don't set to anything right now. And then we're calling this twice. When you have something like this, like a property with a getter, or even with a setter, what the compiler will do behind the scenes, and I'm going to show this in more detail in a second when we go to the actuals class, is it will create a private read-only field for that, and then it will create a getter method and a setter method. However, if you had something like this, then this will create a method without any backend field. And to prove that, we'll do the following. First, since what we want to do is a getter only auto property, like a default implementation, basically, we can do this. We can create a unit ID with a getter only, and then set the default value, the auto property, to GUID.newGUID. And if I execute this code, you see that the ID is the same. And the ID is the same because this flow will create the backend field, which will then just create a getter method that points to the field. So the field value is only set once. However, if I use the Lambda-based auto property and I execute the exact same code, which still compiles, by the way, what's happening behind the scenes is that C# will make a method. It will effectively do this. Actually, let me show you. And what's even more deceiving is that it basically does this. Please allow me to do this. Yes. So it does this, but it allows you to call it as if it was a property. See, now my code broke, even though I did exactly what the compiler would do. So it's problematic because if you used this to initialize an ID once, or even point to a method that, for example, create, let's say we have this, right? Let's say we have a property which returns an HTTP client, and then generate that client, you have a method that creates client. Let's make it here, right? You don't need to implement it, but if you had something like this, then this HTTP client looks like a property that will only be set once during potentially class initialization, but it's made every single time you call this method, and that's where the problematic nature of the feature lies. The fact that you don't actually know what you're getting. Now, I'm not saying don't use this, because there are very valid use cases when you want to use this property. This is more about when you use it, be very careful what you're doing with it. And when you're using code, keep in mind that this thing might actually be a method and you don't know about it. And the only way to know about this is either the NuGet package that you're using is well known and the developer is good, or you have to dive deep in the code yourself. But again, if you don't have access to this code, you're using a NuGet package and the creator is misusing it, you're basically done for at this point. You have an issue and you don't know why, and it's very hard to debug as well. And to show you what actually is happening behind the scenes, just to get a better understanding, in this scenario, like we said, we're gonna get a getter method and a backend field. I can actually prove that by creating a method called public GUID get underscore ID. And as you can see, I'm getting a compiler error here, not because I'm not returning something. I could just return GUID empty, but I'm getting two errors. This getter, because it creates a method with that exact name, the compiler will tell me, hey, what are you trying to do? There's already a method called getID, even though you don't see it. That's because what this will do behind the scenes is create a private read-only GUID ID, and then a getter method that points to it, and of course it will initialize it to a GUID.id. Now if I go to the Lambda, what it will do is, like we said before, and I can actually prove it again by creating a method. So behind the scenes, what this will do is basically that exact same thing, and now you're calling it every single time. So it's not a property, it's a method. Be very, very careful with this. That's a very interesting project to me. That's a very interesting problem to me, and it's one that I've seen wrong so many times. Now the next feature is called default implementation interface members. And what is it? Basically, let's say you have something like this. So you have an interface called iLogger with 2 log levels. We fully own this interface, by the way. I just made it. It's part of a project. And then I have a console logger which implements that interface that is logging with a color based on the level. And I'm using this all over the place in my application. Now, what happens when I have more implementations like this? For example, a logger that is logging in a different way, maybe not the console, but in the file system, or let's say Elasticsearch, and I want to add a method in this interface that is not specific to a logger, but rather the logger concept. For example, I might want to have something like this, where I say void log, and then I have an exception, and then instantly I map that to as a message. I use the exception.toString, and then the level is used as error, because exceptions should be errors. As you can see, when I do that, the class is actually telling me, please implement the missing members. And I would have to write code that says, okay, log to go to the method log in the logger. And then I can say log level dot error, and then exception dot not message to string. But if I have more than one interface implementations, I would have to do this for every single one, and it's always going to be the same, because there's nothing unique to the implementee, if that's even a word. It's to the iLogger concept. So how would you do that, right? And C# developers said, okay, I'm going to add a feature, and it's called default member implementations, or default implementation interface members. It basically means that you can have implementations in your interface. Now, interfaces until now have been a shell, a contract for your system to know how things should be built and how they should come together and what form they should take. But now you can actually use this feature to do exactly what I did in that class, but for every single one of those implementations. And now if I go to the program.cs, I can say logger.log, and I can have a new exception. Something went wrong, right? So if I run this, I didn't break the console logger, and I just added some behavior. I just add a method to every one of those classes that implemented. This was impossible before C# 8, right? Wrong. So if I delete this method here and I take it up here and I go at the bottom, as you can see, this is still failing now because we don't have the implementation. I'm going to go to the bottom and say public static class logger extensions. Well, it turns out, and I'm surprised that not more people know about this, that you can have extensions on interfaces, meaning you could very much do public static this iLogger and then do this. Oh, look at that. Now our code is compiling and I can execute it, and it works the exact same way. And this is not using a C# 8 feature. This is using a C# whenever extension methods became a thing, like 5 or whatever. So we never really had this problem, and obviously this is not the only thing that was added. You can also have here property implementations, because this is members, this is not methods. So fine, I totally get that now we have this new thing. The problem I have with this is that generally, like 9 or 9.5, almost 10 times out of 10, I would go with composition over inheritance. And such a feature could enable you to either use traits or multiple inheritance. And those features are cool. They allow you to do a lot of things, but they also come with a lot of drawbacks. And if they don't get used properly, they can lead to really bad code that's really coupled, tangled together. You lose the concept of an interface, and that's basically the reason why I choose not to use default implementation interface members. Even if you go to the ticket of that original proposal on GitHub, you'll see that the dislikes on the proposal are way more than the likes. I think it's like 3 times more than the likes. And there's very valid reason, and I really encourage you to, I'm going to link that in the description down below. You can go to that and read it for yourselves. I do think it's a powerful feature, but I don't think I gained something that I didn't have, and my code won't change just because it exists. So that's what I have to say for default implementation interface members. Now, the last feature I have is, you should have seen this coming, is regions. Now, that's another feature that I don't usually see unless I'm looking at legacy code. And there's very good reasons for that. You really shouldn't be using it. And I have not a good example. Actually, I have a couple of good examples for why you might want to use it. But again, 9 times out of 10, it can actually hide an issue with your class. Regions is this feature where you can say region and then give it a name. Let's say my private members, and then have a bunch of private methods or whatever you want in here, and then you can collapse it. So let's say private members, and then you can collapse it by doing this, and poof, it's gone. You don't see it. It's just private. It's just down there hidden. The problem with this is that it can cause so many code smells, because your class can go out of hand, keep adding details in it, and just because you collapse it, you don't see it. And it's not like you're just collapsing a method like here, because you can still see the method. This is collapsing everything about it. And sure, Rider and Visual Studio are supporting features to hover over them and see or expand, but this is an ID specific feature as well. So if you go on GitHub, this code will be expanded, and you're gonna see tons of lines of code that you might have forgotten about. They can just hide valuable information about you. And when I'm looking at code, when I'm reviewing, or when I'm going through a project, I want to be able to see what's going on. It's better to have an organized class, let's say private members, constructor, properties, public methods, private methods, static methods, than this. Because you're looking at my screen right now, but you don't know what's in that example region or that fun fact region. And you might want to know. So to do that, I'm going to have to click. And it shows that, yeah, here I had a comment hiding tons of lines of code. But then, is my class bad because it's too big? Is it doing too much? You don't know. You don't know unless you expand. And if you're using regions, it's most likely that you're using them for a bad reason. Also, fun fact, style cop is actually, there's a rule. And I don't know if you know what style cop is a plugin that allows you, basically, it tells you how to write your code in a specific format. There's a specific rule for that to say that you should not use regions, never. And you can say, yeah, that's their opinion, whatever. But I haven't really met anybody who disagrees with that in the past 4 years. Microsoft themselves are actually using them in a few of their projects, but they usually use them to hide documentation, so things like this, which I don't think it's a good reason as well, because I think those things can be collapsed in the exact same way from the ID. At least Rider does it. I don't know what Visual Studio is doing, but they also use it to hide obsolete methods, which I also think is a bad idea, because you can actually hide something that you might want to delete. And in general, there is no good reason to organize your class. It's like a comment. Like, why do you have to tell me? Just have a standard organization, keep your classes small, and so be it. You're going to have a clean class. You don't need regions. This is the common example that I see around the world when I'm looking to legacy projects, You have things like database query methods, database update methods, GitHub API requests, all smushed in this single class, separated by regions. And it gives you the idea of organization, but it's really not organized at all. So please don't use them, but this is totally up to you again. There's no good reason to use them. They will just hide potential issues. It's like, putting a band-aid without treating the infection under your skin or on your skin. So please be very careful with them. That's all I had for you for today. Thank you very much for watching. Special thanks to my Patreons for making this video possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.